algebra with Mr. Toops today. He's the Jedi of Believe, and you're in the office of the Always Believe house. Today, we're going to learn about functions. You did this last year. We're basically introducing functions to you, and you're going to today you're going to figure out if a relation is a function. Pretty easy stuff. So let's start recording this lesson. We are recording. It's going to be a great lesson. A whiteboard magically appears in the office, and we are about to learn about fractions. A fractions is a set of relations, and a relation between two variables, and we're usually going to use x and y because those are the variables. The x and y axis is a set of ordered pairs, and I hope that's what we're doing here. Okay. So when you have a set of ordered pairs, that's a relation. A function is a relation in which every y value, or every, let's just put every y value, or every range, let's be exact here, every range has exactly one domain value. Every range, or y value, has exactly one domain, or x value. So we're looking at the domain and the range, right? Your domain is your x and your range is your y, right? Okay, focus to remember, you did this last year, so if the x's repeat, it's not a function. This is, y'all had this last year, you just got to remember it, okay? If the set of ordered pairs has different x coordinates, if the set of ordered pair has different, it is a function. If the set of ordered pairs has the same x coordinates, it is not a function. If the x's repeat, it is not a function. And remember, this is not in here, but your domain is your x's and your range is your y's, right? Okay, so the x's cannot repeat, okay? And I'll talk about this in a minute, okay? So right here, underline your x values, okay? Notice that these circle the zeros. They repeat, right? Does the x repeat? Yes. Is it a function? No. Your x values are what? -1, 2, 0, and 0, right? So the x's are repeating. It is not a function. Okay, number 2. Underline your x's again. Those are your domains. The domains are 0, 1, 2, and 3. Do they repeat? No. Yes, it is a function. Piece of cake. You did this last year, okay? Really quickly, underline your x's again. Normally, you would put your domain from smallest to largest, okay? We're just going to write them down today. So 0, you have 2 6's, so it's not going to be a function, is it? Does the x repeat? Yes. And is it a function? No. So if the x's repeat, it cannot be a function. And like I said, I'll talk about that in a minute. On this one, underline your x's. So your x's, remember, that's also your domain values, right? So your x's would be 3, 7, -3, and 9. Do they repeat? No, they do not. Is it a function? Yes, it is. And then write this down here. Write down y equals 3x plus 5. That is a linear function, isn't it? If I were to put 1 in that equation, I would get 8, wouldn't I? What if I have 1, 12? Would that be possible? If I put 1 in that equation, I'm only going to get one answer, aren't I? I cannot put 1 in that equation and get 2 different answers. That's why if the x repeats, it's not a function. Does that make sense? When you put a domain in, you're going to get an answer, one answer, right? You can't put the same x in twice and get 2 different answers. If you do, it's not a function. So that's basically what you're talking about here. Every single answer, every domain you put in is only going to give you one answer. You can't put 1 in and get 2 different answers. Now then, these are mappings. So write down mappings. This is another way you can illustrate a function. Notice right here that the 3 goes to the -1. I'm sorry, the 1. So this should be 3 to the 1, 3 to the 2, and 1 to the 2. So right here you have 3, 1, 3, 2, and 1, 2. That's what it looks like to me, because that other bar is kind of in the middle. But this 3 is repeating, right? Your x values are 3 and 1. Does the x repeat? Yes. Is it a function? No. Okay, look right here. The 2 goes to the 2. The negative 1 goes to here and here, right? So you're putting negative 1 in that equation and getting 2 answers, aren't you? That will not work, will it? So your x values are 2, negative 1, and 3. Does the x repeat? Yes. Is it a function? No. You can't plug a number in and get 2 different answers. Hopefully that kind of makes sense. You did this last year also. On a graph, if a vertical line crosses it, the x value repeats. Okay? A relation is a function of the vertical line intersects the graph only at only one point. Okay? So right here, if I were to draw a vertical line through there, it is a function, right? Does the pencil touch the graph more than once? No. Is it a function? Yes. On this one right here, notice I could do this, and that negative 1 would count twice, wouldn't it? So the x's are repeating. So yes, is it a function? No. Okay, so if a vertical line crosses the graph more than once, the x's are repeating. This one right here, it crosses more than once, doesn't it? So you would write down yes. Is it a function? No. These are pretty simple. Right here, a vertical line is not a function. A vertical line is not a function. A vertical line is not a function. So this crosses it twice. Is it a function? No. Okay. So today, you learn what makes a function. A function is a set of ordered pairs, or is a relation in which the x's don't repeat. And if you have a graph of that function, the vertical line will only cross the graph once. If a vertical line crosses the graph twice, it's not a function. And remember, a vertical line is never a function. I hope you have a wonderful day today. Remember, you are amazing. You are created to do wonderful things, and you are awesome.